All right, students, this video is going to talk about how to graph polynomial functions. A polynomial, again, is something that looks like this. 12 is a term, 19 is a term. Each one of these is a term added to another term. So this one's a polynomial because 2 terms would be a binomial, 3 terms would be a trinomial, and after that we just call it a polynomial. Now this is in the family of x cubed. And we know something about the end behavior of x cubed. How we do that is, if you plug the positive number in here, like 10 to the third would be 1,000. So it's going to be way, way up here on the positive end. But if you plugged in negative 10 to the third power, a negative times a negative times a negative, you'll end up with a negative answer, which means it'll be way down here. X cubed actually doesn't do much interesting in the middle. This one will. It has more than just x cubed. Standard x cubed would just be like that. Okay. And that's part of that is if you plugged in 0, you would get 0. So it would pass through 0, 0. This one will not. So we'll get to that. This one's more complex. We got to break it down. Okay, but what we know already, we know the ends will be positive, negative, because if you just look at the x cubed will be far bigger than x squared. So when you plug in a positive, you'll get a positive answer, and when you plug in a negative, you'll get a negative answer. We don't know what the middle is. That's what we have to figure out. So for the middle, we got to use something called synthetic division. We could use long division, but we're going to use something called synthetic. How this works is we take the coefficients there, and the coefficients are these numbers. Just the numbers. And they're all positive this time, so that's nice for us. We take just the numbers, put them in a line there, and we put a little box here. Now what we're checking is, we're going to need to cancel out the 12 at the end. When we do synthetic division, we need a 0 at the end. Okay, so the only way we're going to get a 0 here is something that would cancel with a 12. So like 5 would never cancel 12, because nothing times 5 will get you 12. Or no whole number times 5, shall we say. So it would have to be numbers like 1 or 2 or 3 or 4. Oh, Jesus has a lot. It could be any one of those, or it could be plus or negative too. Positive or negative. The only numbers that will work are numbers that divide into 12. So we have to randomly choose one of these. Okay. And one of them should work. So the other thing I noticed is if they're all positive, the way we're going to use this, we start with a negative in order to cancel. So I'm going to start with a negative 1. Rule is this. Bring down the first term. Then from there you multiply and write the answer up here. Negative 1 times negative 1. Sorry, negative 1 times positive 1 will give you negative 1. Combine these and you'll get a 7. Multiply, you'll get a negative 7. Combine them, you'll get 12. Multiply, and you get negative 12. Combine them, you get 0. And that's our remainder. And as we said in class, that's what we're looking for. We want things with 0 remainder. Okay, so that's what we need. What's the rest of this? This really represents 12. This really represents 7x, and that really represents 1x squared. Okay, so starting backwards from the remainder, then you have the whole number, the x squared. What was this? This was our 0, but it was actually, as a factor, it's the opposite. Okay. What that is in synthetic division, since we do addition all the way through, we make it the opposite factor. So negative 1, the factor is actually x plus 1. Okay, what about this? We still need to break this down again. And we want to break it into 2 factors. Now the nice thing is it's just x squared. So it's going to have to be x times x to get x squared. 12 could be 6 times 2. It could be 3 times 4. It could be 12 times 1. But we need the numbers that can add up to 7 in the middle. So that's going to be 3 and a 4. Okay. Those are the factors, because 3 and 4 give you 7, 3 times 4 give you 12, and x times x give you x squared. So our original thing went from being x cubed plus all that stuff. We started with this, and now it's rewritten like this. It's equivalent to that. If we FOILed all this out, if we multiplied and distributed everything out, you would get back to the start. So how does this help us? So now this is what we call factored form. And what it helps us with is we're going to say what we're really looking for is zeros. And the whole thing here is this. This equation equals 0 if any part of this equals 0. So if this part ended up being 0, you have 0 times anything will be 0. So the answers are what makes it 0. So it's not a plus 1. It's when x equals -1. That's a 0. Not plus 3, but when x equals -3, that makes the whole equation 0. Because 0 times anything, because -3 plus 3 would be 0, and 0 times anything is 0. So we have 3 zeros now. We have 3 zeros. And what we're going to try and do is try and graph it. Now, if you don't have, you really want to have a straight edge for your graphs. Okay. So you can use your ID card. I'm going to use a Costco card. That's just what I happen to have in the wallet here. And we know these are all on the negative side. So, -1, 2, 3 is one of them, and 4. Those are the zeros, and we already said we knew the end behavior was going to be going up on the end, down on this end. What's the rest of our spot? Well, we got to plug in some numbers. So you're going to plug in this into the original equation or into this, whichever looks easier. They'll both give you the original. They'll both give you the same answer. Let me go and write the original up here, just so we have it on the same spot. That's the original we started with. Okay. So how are you going to plug this in? We want to check where's the graph at -2. Okay, so on your calculator, let's see if you can see this. This equation, we need to plug in -2 there. So I'm going to use parentheses -2 to the 3rd power. Let's see if you can see that. Okay. I'll type the whole thing in and you can see it. It's kind of time consuming, and that's why I'm going to show you another method for this eventually as well. Okay, so on this calculator, if you can see that there, let's go back to the beginning. What's nice about this calculator is you can type in everything and go back and check to make sure it's right. So that's -2 to the 3rd plus, again, I'm using that equation, -2 to the 3rd plus 8 times -2 squared plus 19 times -2 and so on. Okay, press enter equals, it equals -2. Wow, all that work. That's what that tells us. It tells us that when we plugged in -2, we got -2. So it's going to go down there to -2. We plugged in -2, we got -2. That's just a coincidence, but that is now our point. We need one more point up here. Okay, so let's see if we can do this here. I'm going to go back to my equation. And what we want to try is -3.5. Find out what that is. And so on this calculator here, what I'm going to do is go delete that. Oh, we already had the negative. Let's delete that, 3.5. And so what I'm going to do is I'm going to change all these 2's to 3.5. And I don't have to recopy everything. It's still time consuming, but it's much better than it would be if we had to retype the whole thing. Okay, 5/8. That's kind of small. Change that to decimal, it's 0.6. So that just barely goes above here, right there. When we plugged in negative 3.5, we got 0.625. So less than 1. A little bit less than 1. So now we know how high it went, and we did that part with the calculator. So it's 2 parts. Synthetic division, actually more than 2 parts. Synthetic division to find the first 0. The factors come out of here. And then you're going to find the zeros. And once you got all that, that's when you put it together with the graph. So we can't get these until it's in factored form. We can't get factored form until we do synthetic division. We can't do the original because it's just standard form is not very easy to tell anything about it. Other than we could look at this and we knew the end behavior. We looked at this, we knew where we should search for zeros. These were our possible zeros. But other than that, the 8 and the 19 didn't end up being any part of our answer. It's just part of our factors. When we factored it, eventually you'd get an 8 and a 19 in there. Anyways, that's how you graph these. We'll do another example after this. Thanks for watching.